Section B, systems of measurement. Different systems of measurements are routinely used in healthcare and in nursing in general. In this section, commonly used abbreviations and equivalencies are going to be presented to you so that you can convert medication calculations from one system to another as needed. In addition, you will also learn about the military time. So these are your objectives. Again, read them thoroughly. And these are your assignments for this section. Number 1, review or learn basic math skills as needed. So optional reading, that would be your chapter 1 from your Med Math textbook from page 1 to 30. Assignment number 2 is reviewing the dimensional analysis worksheet uploaded in Canvas. Number 3, read or review and begin to memorize systems of measurement conversions and associated abbreviations. So for the metric system, you have your weight. So we want you to know kilogram, gram, milligram, microgram. Volume, liter, deciliter, and milliliter. And length, centimeter. Apothecary system, grain and ounce. Household system, drop and teaspoon. And we want approximate equivalents of kilograms to pounds, milligram to grain, centimeter to inch. You have optional reading, chapter 2, pages 31 to 46 of your calculations textbook. And number 4, section B, ATI MedMath work assigned to you on Canvas. And lastly, memorize commonly used equivalencies, which is going to be on the next page that we're going to talk about. So this is pretty straightforward, so I'm just going to basically read it to you. So these are the things that you want to memorize. These are the list of conversion that you want to know for this course. So section B, systems of measurement. Common equivalencies. So for weight, 1 kilogram is equal to 1,000 grams. 1 kilogram is also equal to 2.2 pounds. 1 milligram is equal to 1,000 micrograms. And this is how you write it. 1 gram is equal to 1,000 milligrams. And 60 milligrams is equal to 1 grain. For the volume, 1 ml or 1 milliliter is equal to 15 drops. 1 ml is also equivalent to 1 cc or 1 cubic centimeter. Now, this should be avoided. So using cc should be avoided, but you will hear once you start doing your clinicals that a lot of providers, doctors, NPs, and the older nurses or the nurses who've been in the profession for a little longer, they still use that. So they may ask you, can you give me 1 cc of this? Now, this is not basically standard practice, but you will still hear. So I want you to be familiar with this, but please avoid using it. Now, 30 ml is equal to 1 ounce, and 5 ml is equal to 1 teaspoon. 15 ml is 1 tablespoon, or written as a capital letter T. 100 ml is 1 deciliter. 1,000 ml is equal to 1 liter. For length, 1 inch is equal to 2.5 centimeters. So for weight, pounds, this is how you're going to see it. Pounds, so this is abbreviation that you'll see. And you can also see this pound symbol right here. Grams, so either just a G or GM. Grains, as lowercase gr with Roman numerals after. For example, is 5 grains of aspirin, then it will be written as aspirin gr and the Roman numeral of 5. Now for volume, cubic centimeters or cc Again, this is no longer acceptable. So please don't use it, but you want to be familiarized with this because some people may still use it. So you'll hear some other nurses and providers saying CC, but definitely don't use it. So 0. So 0 before a decimal for a number less than 1, such as we mentioned earlier in section A. So 0.5 ml, that's an example, but not after a whole number. So example 4 ml. You don't add a 0. So it's just 4 ml. Now with fractions, you want to use decimal for volume of liquids. Use fractions for solids such as pills or capsules. Now again, with capsules, we don't really give half a capsule. It's more whole numbers. So we're talking here more about tablets. So use fractions for solids. Again, for liquids, you use decimal. And for your solids, you want to use your fraction. So number 6, you're going to see this a lot when it comes to electrolytes. So MEQ, so milliequivalent. So that's what MEQ means. So it's a measurement of electrolytes such as potassium chloride. So you're going to see it in 20 MEQ. So that's what it means. So this concludes the systems of measurement. So we're going to go next to dimensional analysis. So for dimensional analysis, you can actually read this in your textbook, calculations textbooks, page 89 to 90. A fourth method of dosage calculation is called dimensional analysis. So they have other methods that they're using in your textbook, but this is what's going to be expected from you. So this method is used extensively in mathematics and science, especially chemistry calculations. Students often say that once you master dimensional analysis, you tend to use it all the time because it's simpler and more accurate than other methods. The dimensional analysis method uses terminology similar to that of other calculation methods. There are several ways to set up the dimensional analysis equation. One way is to set up the equation starting with what unit of measurement you're solving for and how the dose is supplied. Add to this what you have, then add the desired or ordered dose. Then solve the equation. The equation is set up like a fraction with the appropriate numerator and denominators, but looks slightly different. You can set up the problem using the same terms as above. So over here, so if you're going to set it up as fraction, so you have how it's supplied, what you have, right, times, so in between here, times the desired dose equals to X or the amount that you need. So in this example, we are solving for how many tablets of Coreg or carvedilol to administer. So place tablets first in the equation. So the tablets. The dose applied is tablets, and the dose that we have is 12.5 milligrams per tablet. So how do you write that? How do you write that here? So for one tablet, so on the top, on the numerator, you write one tablet over, right, underneath, 12.5 milligrams. So that is your dose. So basically, this is your supplied. So how is it supplied, right? How do you administer it? And this is the dose. The dose that you have. Then add the desired dose of 625. Again, so we're building on this formula. So we already added what we have, right? How it's supplied. And what do we have? What the dose? Right? And then so this you multiply by 6.25, which is, right, what you need. Need or want. That's what you need or want. That we have that. So according to the basic rules of reducing fractions, So review chapter 1 if needed. The 2mg designations cancel each other. So as you can see here, this is what they mean. So when you're multiplying fractions, right, and then you also have your units of measurement, so this is canceled by this. So now you're left with just the tablet. So the setup should look like this. So once you take those out, it's going to look like this right here. So one tablet, right? So you have one tablet over 12.5 times 6.25. So drawing a circle around the desired measurement system helps you know what you are solving for. This reminder is especially helpful when the equation becomes more complex. So as I did here, this will remind you of what you're looking for. So you multiply the numerators, multiply the denominators, and then divide the product of the numerators by the product of the denominators. So in this example, the numbers in the numerators are 1 times 6.25. So we have 1 times 6.25 equals to 6.25. And then the only number in the denominator is 12.5, as you can see here. Then you divide 6.25 by 12.5 to get 1/2 tablet. So the answer is 1/2 tablet. So in this example, it would look like this, right? So basically that's what we did. You multiply that, right? So let's go over and do the whole problem together. So when you're using dimensional analysis, you could also set the equation starting with the desired dose, then adding the dose supplied and dose you have. For example, in the problem above, the equation would look like this. So that can be preference. You can set it up either or. You're going to basically have the same answer. On the previously, you learned that you place the supply and have first times the desired dose, but you can actually change it to the desired dose first times your supply and what you have. So if you take that formula and you would substitute it, you would solve the same way by canceling the units of measurement, reducing if possible, and you will have the same answer. So as we have here, so earlier, remember we circled what we needed, right? So this ultimately is what we need. And what's gonna happen is, right, we cancel this out, so we're left with just a tablet. And if we multiply it, 6.25 times 1, then we have 6.25 over 12.5, which is what we have over here. And once you divide 6.25 divided by 12.5, what you get is 1/2. And make sure you write your tablet. Always write your unit of measurement or label. So that's the answer. So either way of setting up the dimensional analysis of the equation will work. So this is to summarize again or to list the steps for dimensional analysis. You can use this as a guide, especially if you're having a hard time with it. I say follow this step by step and it should lead you to your answer. So number 1, you write your formula. So again, you can use either or, right? You can start with the desired dose times supply divided by the dose you have, or you can start by supply over what you have times, right? So don't forget there's times here. This is what it stands for. So this is a fraction, right? This is a fraction or division. So, and then times desired dose. Number 2, begin by placing a line across the paper to serve as a division between the numerators and denominators in your problem. So basically, you can start by doing that, right? So your numerators and denominators. Then determine the value in units of measurement of the following. So you want to know what is your desired dose, how is it supplied, basically how are you going to administer it. Does it come in tablets, right? Does it come in capsules, mLs? So you have to figure that out. And so, and how it is supplied, how much is in it in that form that it's applied. So how many milligrams, or depending on what medication it is. So what's the dose? Now, step number 4, you plug in the designated values and units of measurement in your formula. You may need additional values to convert units of measurement. So if you need to convert, then definitely you need to add more to that. Now, in step number 5, you determine the unit of measurement that is needed to administer the medication, and you circle it. Kind of like what we did earlier, right? We circled tablet. After that, you cancel units of measurement that are not needed. So again, just like what we did with milligrams. So we had milligrams on one side in the denominator, and you have the other one on the numerator on the other side. So that cancels each other out. After you do that, you multiply. So step number 7, multiply all the numerators and then multiply all denominators. Then step number 8, you divide the numerator by the denominator. But do not round until your final answer is obtained. And lastly, step number 9, you round your final answer and write your desired unit of measurement. So following the steps that we talked about, we have example number 2 here. So the healthcare provider orders 0.05 milligrams of a medication. The medication is supplied in 50 microgram tablets. What dose will the nurse administer? The first step is over here. You want to write your formula. So how do we write it? Again, you can do either or. So you can do desired dose times supply over what you have. Or if you prefer, you can do supply have times desired dose. So begin by placing a line across the paper to serve as a division between the numerators and denominators in your problem. So in here, I just illustrated how I was going to put the line in there. And usually I put another line across to kind of know which, where to divide it or where to separate the values. Now, step number 3, according to our steps, right? Determine the values and units of measurement of the following. So what's our desired dose? What's our supply and have? So based on what we were given here, so what is the desired dose? So what did the doctor order? So it says here 0.05. So that's what we write here, 0.05. 0.05, so the desired dose. So order. So that's the order, the doctor's order, or the NP, or the PA. Now, the supply, how is it supplied? In what form? How are you going to give it? It says here that the medication is supplied in 50 microgram tablets. So this is how it comes. So we have one tablet, right? Now, have, meaning in that tablet, how much? So what's the dose in each tablet, right? So that's what it means by that. So once we figure out the desired dose, supply, and have, we go to the next step. So we have step number 4. So we plug in the designated values and units of measurement in our formula. So Go back here. That way you can see where did we get it from. So on the top part, right, we have the desired dose because that's what we wanted to do. So for this one, we're going to use this. Again, whatever one you feel comfortable using, that's fine, but this is usually what I use. So I start with what I want. So the desired dose is 0.05. So we have it here. Now supply. So how is it supplied? It's in one tablet. And have, right? How much is in one tablet? It says it's 50 micrograms. So as you can see here, well, I have a little problem here, right? The doctor ordered milligram, but what I have is microgram. So what am I going to do? Well, that's when we have to take in consideration our conversions. So I can't really do the math without converting it first. So that's when I try to figure out how do I convert my milligram to microgram or vice versa. So what's your conversion? So 1 milligram, you can see here 1 milligram is equal to 1,000 micrograms. So based on what we have here, milligram, the milligram goes to the bottom so it can cancel out. And then the 1,000 micrograms goes to the top so that it will cancel this one out. So if you see this. Okay. So this is where we're conversion from one unit to the other. Sorry, it's hard to read. Anyway, so once you determine, after that, you determine the unit of measurement that is needed to administer the medication. So again, how am I going to give the medication? Well, as we know, it says that it's supplied in tablets. Well, that's going to be how I'm going to give the medication in the form of tablets. So that's when we circle it. Once we determine it, we circle it. Step number 6, this is the time when we cancel the units of measurement that we don't need. Again, as we talked about earlier, right, we converted the milligram to microgram. So we cancel this out. These two cancels each other out, and then this one will cancel. So micrograms will cancel this one too. So the only thing left is our tablet, right? And after we do that, step 7, we multiply all numerators and multiply, sorry about the misspelling, all the denominators. So this is what we do, right? This is multiply. So what? 0.05 times 1,000 times 1, we get 50. And then 1 times 50 is 50. Now we divide the numerator by the denominator. So we have 50 divided by 50, then we have 1. Now, this is not our final answer yet, right? What do we need? Well, we need the unit of measurement or label. So don't forget about that, because if this is your final answer, that's going to be wrong. You want to make sure you indicate you have 1 tablet. So that's your answer. So round your final answer if it needs to be rounded, and then write your desired unit of measurement. All right, so let's do another example. So here we have example number 3. The provider ordered to administer 15 MEq of a medication. The medication available in the Omnicell comes in 10 MEq per 5 ml. how many ml will the nurse administer? Again, let's go to step number 1. What's step number 1? Right? We write the formula. So that's that. So now what's step number 2? Well, step number 2, we place a line across the paper to serve as a division between the numerators and then the denominators. Next, we determine the value and units of measurement of the following. So we want to know what's our desired dose, how is it supplied, and what do we have. Again, we look back to the scenario, to the case, right? How do I know where to find things? Well, easy. Your desired, so the desired dose is the order. So this is your desired dose. I'll just put an abbreviation here, just so you know where to find it. Now, what's the supply? Well, supply is basically how it comes. How am I going to administer it? And it says here, it's already asking you anyway on the question itself. It doesn't always do that on your, depending on the question, but in this specific case, it's asking you ml, right? How many ml? And over here too. So it's supplied in 5 ml. So it comes in 5 ml. So this is your supply, right? And the 10 MAQ would be your have, which is equivalent to your dose. So how much medication, what's the dose in each 5 ml, right? So that's where you're getting that information. So again, you write down your desired dose is 15 MAQs. It's supplied in 5 mLs, and it has 10 MAQ per 5 ml. So after that, we plug in the designated values and units of measurement in the formula. So on top is your desired dose. So we have 15 MAQ, and times, I like to write this because sometimes it's not clear for some people. But it's nice to just write it down, kind of to remind you, yes, you need to multiply. And plug in 5 ml as your supply and 10 MEQ as the dose that you have. And we go to step number 5. So again, we determine the unit of measurement that is needed to administer the medication. So in this case, it's a liquid form, right? So there's no tablets, capsules. In this case, we need ml. That's how we're going to administer it. So we circle that. And after circling that, we cancel the units that we don't need. So this too, the MEQ cancels each other, right? So now you're only left with your ml, the unit of measurement that you need. On step number 7, you multiply. Again, sorry for the misspelling. I think I have it right in your list, but please correct it in case. So you multiply all the numerators and you multiply all the denominators. So again, 15 times 5, I have 75, and this is basically 1, right? So if there's nothing there, it's usually 1. 1 times 10 is equal to 10. Then, after that, you divide the numerator by the denominator. So you have 75, right, divided, this is what's happening, 75 divided by 10. So then you have 7.5. Now, is this our final answer? No, it's not, right? Do not, and then remember, do not round until your final answer is obtained. So as we mentioned earlier, if it's greater than 1 ml, we want the decimal points up to the tenths. And your last step, make sure you write your desired unit of measurement. So after we rounded, there was really no need to round here because it was already on the tenths place. after rounding, you write your unit of measurement. So this is your final answer, 7.5 mLs. So these are some practice problems. So please practice the following problems using the dimensional analysis that you just learned and round off to the nearest tenth, label your answers correctly, and always repeat your calculations to make sure that there are no errors. If the answer seems unreasonable, recalculate your response. So you have all this. So please practice in calculations. Definitely you need to put in some time and really practice them. And you have the answers at the bottom. Now, this is for you to really calculate. So you want to calculate it first and basically compare your answers. And so if you don't get the right answer, try to figure out where did you go wrong. And we can go over it some more. If there's anything that we need to clarify and go over in class, we can do that. And or if you want, you can also send me questions or anything that you want to clarify via email or on inbox, on Canvas, or on the Remind app. All right, so this is section B. So this sheet right here, so this is a one-page dimensional analysis drug calculations guide. So you can also use this if this is something that you can understand better. This is basically your guide on how to do dimensional analysis during drug calculations. So again, read it. It's very similar to the one that we just covered. So it goes over what is dimensional analysis, how do you formulate your problem. So you have these steps. So you can use this too if it's easier to understand. And again, you also have some rounding guidelines or rules here. And then you have your helpful hints. And just very briefly, I wanted to go over this printable military time conversion chart. So this is how you convert from civilian time to military time. Midnight or 12 a.m. starts with 000, and then 1 a.m. so it's 0100. So you go on all the way to 12, right? So after 12, so everything is quite straightforward until after 12. Now in the afternoon, after 12, instead of writing 1 p.m., we use 1300. So 1300 and so on. So 2 o'clock is 2 o'clock p.m. is 1400, 3 p.m. is 1500, 4 p.m. is 1600, 5 p.m. is 1700, 6 p.m. is 1800, 7 p.m. is 1900, 8 p.m. is 2000 or 2000, 9 p.m. is 2100, 10 p.m. is 2200, and 11 is 2300. And again, after that, you go back to midnight. So midnight is 000. And that's really a brief military time conversion chart. And that's it for section B. Thank you.